So here we are given the value of sine A, so that's 3 over 5, and our angle A lies between 0 and pi over 2, meaning it is in the first quadrant. And cosine of B, that has a value of negative 12 over 13. So here angle B lies in the third quadrant. So let's verify that. So we have our Cartesian coordinate plane. So in the first quadrant, our angle lies between 0 and pi over 2. Then we have the second quadrant where the angle lies between pi over 2 and pi radians. In the third quadrant, we have an angle lying between pi and 3 pi over 2 radians. And in the fourth quadrant, we have an angle lying between 3 pi over 2 and 2 pi radians. So clearly, A is going to lie in the first quadrant, and angle B, so it's given here that is lying between pi and 3 pi over 2. So that means it lies in the third quadrant. Let us begin. The first, we'll have to find out the value of sine A minus B, cosine A plus B, and tangent of A minus B. Let's note down the given for value, meaning we have sine A minus B. So this can be also expressed as sine A times cosine B minus cosine A times sine B. Coming to the second one, we have cosine of A plus B. So cosine of A plus B, that's equals to cosine of A times cosine of B minus sine of A multiplied to sine of B. And we have tangent of A minus B. So that will be equals to tangent of A minus tangent of B divided by 1 plus tangent of A times tangent of B. This clearly tells us, since we have the value of sine A and cosine B, we need to find out the value of cosine of A and sine of B. Also, we'll have to find out the value of tangent of A and tangent of B. Let's first find out the individual trigonometric ratios. To begin with, we'll start with our first ratio. We have sine of A, so that's equals to 3 over 5. Fine. So using this, we can find out the value of cosine of A. So to find out the value of cosine of A, we're going to use the identity sine squared theta plus cosine squared theta. So that's equals to 1. So cosine theta can be also expressed as plus or minus the square root of 1 minus sine squared theta. And if we want to find out the value of sine theta, in terms of cosine theta, that will be plus or minus square root of 1 minus cosine squared theta. Since we are interested in finding out the value of cosine of A, so we're going to use this particular formula. This will be equals to plus or minus square root of 1 minus sine squared A. So we have plus or minus 1 over plus or minus square root of 1 minus sine squared A. So sine A, that's already given as 3/5. So we have 9 over 25. So when you solve for this, we're going to get two values, plus or minus 4 over 5. So it could take either a positive value or a negative value, but it's been mentioned here that our angle A lies in the first quadrant where all trigonometric functions are positive. Since all trig functions are positive, so cosine of A is going to give us a positive value, which is positive 4 over 5. Now that we have the value of sine A as well as cosine of A, let's also find out the value of tangent of A. Tangent of A, that's the ratio of the sine function to that of the cosine function. Now sine of A has a value 3/5, and cosine of A, we found out that this value is positive 4/5. So this is equals to 3 over 4. And you can notice here that we are getting a positive value, which makes perfect sense because we are in the first quadrant where the tangent function is also positive. Next, we need to find out the value of sine B and tangent B. So we're going to use the value cosine B is negative 12 over 13. So let's note it down. So we have cosine of B, that's negative 12 over 13. So first we'll find out the value of sine B. For that, we are going to use this formula. So sine of B will be equals to plus or minus square root of 1 minus cosine squared B. So we'll use the value of cosine squared B. So we have plus or minus square root of 1 minus cosine B being negative 12 over 13. So on squaring it, we're going to get 144 over 169. So that gives us a value plus or minus 5 over 13. So we are getting two values, a positive 5 over 13 and the other one is negative 5 over 13. Now we need to check in which quadrant B lies. So it's mentioned here that B lies in the third quadrant. Now we know that in the third quadrant, the tangent function is positive. Tangent and cotangent are positive. Everything else is negative. Since we are finding out the value of sine b, so we'll have to consider a negative value. So value will be negative 5 over 13. Fine. So we have the value of sine b. Now we can immediately find out the value of tangent of b. Tangent of b will be defined as the ratio of sine of b to that of cosine of b. Let's plug in the value. Sine of b, we have found out that this value is negative 5 over 13. And cosine of b, that's already given as negative 12 over 13. Solving this ratio, we get the final value 5 over 12. And here we're getting a positive value, which tells us that b is indeed lying in the third quadrant. Fine. Now that we have the value of all the 4 trigonometric, we have 1, 2, 3, 4, 5, 6. We have a total of 6 trigonometric ratios. We can use it to find out the respective values of 1, 2, and 3. So let's begin. So we'll first start with the first trigonometric ratio, sine of the compound angle A minus B. So we have already specified the formula. So we have the first term given by sine A multiplied to cosine B. So sine A, that's positive 3 over 5, multiplied to cosine B, which is negative 12 over 13. Minus the second term is cosine of A times sine of B. So cosine of A, that's positive 4 over 5, multiplied to sine b, which is negative 5 over 13. So that's a very simple calculation. When we solve this, we get the value negative 16 over 65. Coming to the next ratio, we have to find out the value of cosine of a plus b. Now, the first term, we have cosine a times cosine b. So cosine a, that's positive 4 over 5, multiplied to negative 12 over 13. So that's the value of cosine b, minus the second term, which is the product of sine A and sine B. So sine A, that's 3/5, multiplied to sine B, so that's negative 5 over 13. So when we solve this, this is going to give us the value negative 33 over 65. And then we have the third trigonometric ratio, tangent of A minus B. So this will be equals to, so we have tangent of A minus tangent of B in the numerator. So that's 3 over 4 minus tangent of B. So that's 5 over 12. All divided by 1 plus tangent of A, 3 over 4, multiplied to tangent of B, which is 5 over 12. So we solve this, and this is going to give us a value 16 over 63. So we have finally found out the value of each trigonometric ratios.